YouTube. I'm Philip Meyer, I'm an electronics engineer, and one of my hobbies is to rebuild and restore old computers. And it's the first time I'm wearing this t-shirt. It was a birthday present of a friend of mine years ago. By the way, thank you Tobias for keeping running server up and running. Very good service. Drop me a line if you see this. So yeah, what do we want to deal with today? It's basically about this. Yeah. So what is it? Oh, you can see it. But yeah, anyways, this is the first time I do the tripod game here. So this is an ST225 hard drive. It's one of the most widely sold hard drives made by Seagate. It's widely available. Unfortunately, it's supported by my pdp11. Yeah, so this is a Winchester drive. It connects to an Winchester QBus controller, so-called RQDX3. It's an MSCP controller. I'll show you that later. The problem with these Winchester drives is, yeah, maybe the younger folks of you only know this IDE drive and these SATA SATA drives today. These modern drives have a built-in controller. This drive has no built-in controller. This circuit here is basically only an analog circuit and a bit digital stuff to spin up the motor and move the head back and forth, but it's not really a controller. It just, like a floppy drive, it gives out the demo-related data on the raw encoding basically, and that connects to a Winchester controller. On a regular hard drive you have today, it's all integrated onto the hard drive. So there's only the bus, the SATA, IDE, whatever bus, and yeah, what it connects to, and yeah, for these drives it's different. Yeah. So what's the problem? You need special software to format this. You cannot just do, yeah, maybe let's assume a DOS computer. On a DOS computer you cannot just insert this drive and do format C. That won't work. You need to low-level format this drive first. You need to locate bad blocks and write it into a certain sector, and you have to do all this low-level stuff first, and then it's okay. Then you can do the format C on top of this. On the pdp11 it's similar. You have to low-level format this first until this works. This comes from maybe a DOS computer. I have a few of them. Yeah. So the basic problem here is to load a formatting tool onto the PDP and format this hard drive. Yeah, since I don't have any floppies, I don't have any tools, my pdp11 can basically write from the trash container to me, via non-adaptation of course. So, yeah, but there's a trick I will show you today, how we load a formatting tool into the PDP and format this hard drive. So we will walk through the whole process, and hopefully this helps to restore your pdp11. Or yeah, maybe you just have fun learning some things and learning stuff, a bit of this historical stuff. So let's go. So the machine is running now. Here I set it up the hard drive. I'm not sure if it works. Maybe I have to pick up another one. And I have also this one. This is the one that was built in my first video. I took it out because it has double the size. It's an ST251. I do this for a good reason. I want a small hard drive to start with. You will see later why this is of fortune. So yeah, the machine is running now. It's running its bootstrap here. You see it tried to boot several times without success. So the first thing we do is to bring the machine to the so-called ODT-Prompt, which is done by pressing Halt right here. We don't leave that in put it out immediately, because if you leave this button pressed, then you won't be able to start the machine again, and yeah, so we don't want to fuck up this later. So now the machine is on the ODT-Prompt, and yeah, I think this is the program counter. The screen is a bit bright, so now it gives a much better image. So yeah, what can we do with this ODT? This is basically the modern form of the switch panel stuff. And yeah, you can examine registers, and of course you can examine the memory, at least the part of the memory where the MMO is currently pointing to, but yeah, that's a different question. So in the ODT syntax, please stay on screen. So yeah, it saves energy here. Okay, let's go on. So if you want to see what is stored in the memory, you start with the address where you want to begin examining the memory. So in our case this is 0. So start with 0 and then the /, and what we get is the memory content at the position 0. And we don't press enter, because if we press enter and CRLF is issued, and that would get us out of these basically viewing mode. That is also a writing mode, you see immediately, but yeah, I present it first as a viewing mode. So we press Ctrl J, it only issues a line feed, I think. So, and what we get is a memory dump. See, the address is increasing, it's incrementing by 2 always. Yeah, it's a 16-bit machine. I think that's the reason why it increments the address counter by 2. Okay, if you want to write to the memory, we do the same. We start with 0 in this example, and then we do the /. We are at address 0, and then we just input what we want to have at this address. And it's octal. Also the addresses are in octal counting. You see that because it wraps around at 6. Yeah. So you have to think in octal, but yeah. Let's say I want to have an 11 there. So I press Ctrl J, and yeah, this should be 23, and yeah, and this is a 42. And yeah, I finish this with enter. Now let's see if that what I typed, you see it's incremented automatically. Let's see if that what I typed really really stored in the memory. So / and Ctrl J, and here we go. Here it is. So what I did manually here, of course this can be done by a Linux computer and a serial port. A C program can do this automatically. So what I did, I wrote a little C program, and since I have downloaded a dump from the formatting utility from the web, I can load this into the memory, and yeah, that's what we do now. So now we are on the PC side again, and of course I didn't work it out all by myself. We use the webpage David's blog. This guy worked out the procedure of loading the formatting tool via ODT, and he did it with the software, with the term with static timings and stuff, and I thought that I could at least make this procedure a bit more comfortable. Yeah, so I wrote a little tool. It's written in C. It's called pdp11 tool, and it has some basic conversion functions and stuff. The link is in the comment section anyway. You can download it and try it by yourself. So we need this command line here, which will upload the zrqc OCT. OCT is just the octal dump, just the octal numbers line by line in a text file, nothing special. So And yeah, you can download these octal dump from here, but you have to remove the 0/ in the first line, as my program expect just the octal numbers. Yeah, this is where it where he works this stuff out. Yeah, and here's a link I also found there, which describes the format, the format procedure itself. It also has a pinout of the zrqc. But what we need first is here, we need to decide which drive we have. And here's the conversion table with the deck name and the original name. And here we see the ST225 and ST251. So I have the 20 meg version right now, so it's an RD31. Now let's write the program into the pdp11's memory. So let's go. Oops. Oh yeah, the window is not the lost the focus. So it got the ODT-Prompt. It's very fast. David states that he needed about an hour, and yeah, this basically it's minutes. So done, it's loaded. And yeah, now we start the program and we'll see if it formats the drive. So it's recommended to switch off all drives that should not be targeted by the formatting sequence. So for drive 1, which is not existent, we just do it. And yeah, of course he takes the floppy out, that these things are sure, and yeah, and then hopefully everything goes well and the drive gets formatted. Okay, we are now back. It's the ODT-Prompt here, and I will start the XXDP zrqc program now. Normally these programs output a restart address when running normally. In this case the restart address is known to me, and I will type it in followed by a G character, which is the go command in ODT. So in my case, basically in all cases which are performed with this dump, it is 14, 5, 7, 2. So and now we see a DR prompt, and what I now will do is I will exactly reproduce the sequence which you also find on the website. So let's go with start, and yeah, we run that 1 unit. Yeah, this is correct. What unit do I want? It's unit 0. Yeah, we don't want this. No. No. Of course, we want to proceed. Now it's looking for the hard drive, and yeah, it asked me if I want to use the block information from the manufacturer. I don't want to use that. And yeah, that's what I want. I don't know what it is exactly, but yeah. As I said, I reproduce the thing I found on the web. So now this is an important parameter. It specifies the drive type. In our case, it's an RD31. Look at the conversion table I showed you previously to know which is the deck name for a drive. In my case, the ST255 is an RD31. so I use 4 here. So yes, and now I have to type in the serial number of the drive. This is 62669609 in my case. Should be correct. And now it's starting the formatting sequence. So this will take a while. Okay, while the drive is happily formatting, I come up with some theory about hard drives. What you see here are 2 regular PC hard drives. This one is a bit older, it's a bit vintage, it's a 540 megabyte hard drive. The concept of hard drives didn't change much, except with the SSDs there's a new technology around, but all of them consist of a disk and an ARM which is moving back and forth over the disk and pick up the data. So what's so special about these hard drive compared to an Winchester hard drive like this? It's the same concept, and we have the electronics underneath. The difference between these 2 hard drives and this is basically the bus. This hard drive is more like a floppy drive. It has not much intelligence inside, while these hard drives have all the controller stuff and bed block management is all inside here, inside the electronics. And what comes out is only the bus where the computer says read or write these blocks without caring about bed blocks and stuff. So how is it done for the Winchester drives? Yeah, it's easy. All the logic which controls it all is in the controller. This is the controller from the pdp11. Yeah, it has some ASICs on it and 2 EPROMs is the firmware of the controller. So basically this is a computer in itself that controls the hard drive, and these 2 things are merged into one unit, which is in the today's hard drive. This is the controller, which is basically this. Yeah, these 2 electronics moved into these electronic parts on the modern hard drives. This makes it way easier for the system integrator or customer to handle the hard drive. Because if you take a Winchester hard drive and if you change the controller circuit, just because if you put it from one computer to another, it might not work because the controller is different, and yeah, basically everything about the drive could be different there. Yeah, so this makes it extremely difficult to back up Winchester drives or to restore data if you don't have a working controller drive ensemble. So let's put this aside. I've opened this Winchester hard drive because it had a head crash. This is what it looks from inside. On modern hard drive you would have a voice coil for the head positioning mechanism. In this case it's a stepper motor, which was very common in these ages. And this moves the head back and forth over the hard drive. And yeah, here's the very end. And here's the very end on the other side. And this is done while the disk is rotating. Yeah. And yeah, this hard drive has a head crash, and yeah, I can see it on the outer ring on the lower disk. These drives, especially these ST225 drives, are normally very reliable, very rugged. They are really masterpieces of engineering work. This is what's special for this hard drive is. I don't see a date here, but we see something else. Here is written hard error map. Every hard drive, even the today ones, have errors and defective tracks basically. There's also some due to manufacturing, you cannot make a disk that is entirely perfect. On these hard drives, on the modern hard drives, the controller is inside integrated and you can store the bad blocks and bad tracks there. But on these Winchester drives, this was impossible, as the controller is outside and chosen by the system integrator or user. So the manufacturer listed the bad block on a sticker on that hard drive, and you had to type in this before performing the formatting sequence. I did not in my video, but hopefully the formatting software is recognizing this and managing this for me. Yeah, it's very heavy, very sturdy stuff. And yeah, last but not least, I want to show you how it looks like when the hard drive is spinning up and the arm is moving back and forth. In this case, I have set the factory test jumper, which is making the pickup arm going back and forth infinitely. So yeah, let's connect the power and spin it up. The sound is basically because of the head crash. Normally it would sound much better. This is because the drive cannot be sure that the arm is at the very end. And now it's moving infinitely back and forth over and over again. Okay, let's disconnect the power. And it's spinning down. The thing with this hard drive is it doesn't have an auto parking mechanism, so the arm is staying right where it is. Normally, if you park the drive using appropriate software, then it would, I think, then it will drive the arm right to the very end. There are newer versions of these early hard drive types which support auto parking. I think the 251 does it, but I'm not sure. So yeah, let's now see if the formatting sequence has completed. Okay, you can see that the formatting utility has formatted the drive successfully. In the meanwhile, format took about 8 minutes, which can be seen in the log above. So, this is a good result. I would say problem solved, at least one of the many problems I have with pdp11. If you want to reproduce this experiment with your pdp11, you might be interested in the jumper settings. Here's the setting I have used, and the terminator resistor array is in its slot as well. The job is done, the hard drive is formatted, and in the next video I will show you how to create a boot floppy for your pdp11. Okay, that's it. Bye bye.